Almost as important as the microphone is the microphone preamplifier, or mic pre, mic amp, or just preamp. This circuit boosts the tiny output voltage from the microphone up to a level, which is called line level, that's easily sent around the studio to consoles, outboard gear, and DAWs. Let's see how it works. Most DAW interfaces and almost all consoles have mic preamps built into them, but in most cases the quality of their circuitry isn't nearly as high as what's available in a dedicated outboard piece. That said, each mic pre has its own sound, and most engineers will select the mic pre and microphone combination because of the sonic color that the combination provides, which makes the captured audio fit the music better. Usually a dedicated mic amp sounds a lot better than the ones included in a DAW interface or console. An outboard pre generally provides a signal that has higher highs and lower lows, meaning it has a better frequency response, and is clearer and cleaner. This increased quality comes at a price, as an outboard mic pre can cost anywhere from a fairly inexpensive $100 to several $1,000s per channel. As a comparison, a mic amp on a cheap interface frequently costs less than $2. In many cases, you get what you pay for. Mic preamps do only one job, and that's amplify. As a result, they usually don't have that many controls, although the more expensive exotic models might have some extra features. Here are some of the parameter controls that you might find on a typical preamp. The gain control, which is sometimes called level or trim, is one that every preamp has. It's essential because it controls how much the microphone signal is amplified. Most mic preamps have about 60 dB of gain, which means that the mic signal is amplified by a factor of 1,000,000. There are some that have as much as 80 dB of gain to accommodate low-output ribbon mics or field audio recording where the signals captured by the mic are extremely quiet. Some sort of metering is also found in every preamp. This can be something as simple as a single LED indicator that signals an overload to a full-on ladder-style LED peak meter as found on consoles and DAWs. The input pad is a switch that attenuates a signal coming from the microphone anywhere from 10 to 20 dB. This keeps a hot signal from the mic from overloading the input circuitry of the mic preamp. It's used when the mic is trying to capture a very loud sound source like a snare drum or loud electric guitar. The phase switch changes the polarity of the microphone signal due to either a misplaced or miswired microphone. Set the switch to the position that has the most low end. The high-pass filter allows only the high frequencies to pass, which means that the low frequencies are attenuated, which is why it's sometimes called a low-cut filter. The frequencies that are attenuated are usually anywhere from 40 Hz to 160 Hz. They're cut off in order to eliminate unwanted low-frequency noise like the rumble from heavy truck traffic. On most preamps, this frequency is fixed, but on many models it's variable. It was pointed out in a previous movie that condenser microphones need some sort of power in order to operate. Mic preamps and recording consoles frequently supply that power. This is a standard 48 volts, which is why it's sometimes labeled as 48V. It's called phantom power and is a pretty standard feature on most dedicated mic pre's. Almost all mic preamps that are made these days have an input where you can plug in an electric instrument like a guitar or bass to turn the unit into an active direct box. It's sometimes marked as high Z because the input is a high impedance input which is matched specifically for these kinds of instruments. To sum it up, the microphone preamp boosts the tiny output voltage from the microphone up to a level that can be used by the other devices in the studio. All mic pre's have a gain control and some type of overload indicator, but you might also see an output gain, impedance, input pad, phase, phantom powering, high-pass filter, and more extensive metering.